Hi kids, so today our topic of discussion is trigonometric identities. We have already done an introduction on that, okay? Just to recap, sine square theta plus cos square theta gives you 1, which means 1 minus cos square theta is sine square theta, 1 minus sine square theta is cos square theta. The next identity, 1 plus tan square theta is sec square theta, which means tan square theta will be sec square theta minus 1, and sec square theta minus tan square theta is equal to 1. There was one more, 1 plus cot square theta is equal to cosec square theta, which gives us cot square theta as cosec square theta minus 1 and cosec square theta minus cot square theta is equal to 1. Then we had reciprocal relationship, which means sine theta is 1 by cosec theta because sine and cosec are reciprocal to each other. Similarly, cos theta is 1 by sec theta and tan theta is 1 by cot theta. Then we had quotient, that is tan theta can be written as sine theta by cos theta. Similarly, cot theta can be written as cos theta by sine theta. Now let us look at this sum. 12 part 1. We need to prove that sec A plus tan A bracket 1 minus sine A equals to cos A. Now look carefully, your left hand side. Sec A plus tan A and 1 minus sine A. Now sec A, can I write 1 by cos A? Tan A, I can write sine A by cos A, isn't it? 1 minus sine A. Now cos A taken LCM, so it's 1 plus sine A multiplied by 1 minus sine A. Now look carefully in the numerator, 1 plus sine A, 1 minus sine A is A plus B, A minus B. That's A square minus B square by cos A. Now 1 minus sine square A is cos square A, we know that, by cos A. So cos square A by cos A, cos A will be left and that is equal to RHS. Proved or verified? Done. Now look at sum number 12 part 2. Prove that 1 plus tan square A, 1 minus sine A, 1 plus sine A is equal to 1. Very easy, just look over here. 2 steps. Now this is 1 plus tan square A, 1 minus sine A, 1 plus sine A. Now we know identity. 1 plus tan square A, 1 plus tan square theta is sec square theta. So this will be sec square A. And this is C, A minus B, A plus B. So we can write this as A square minus B square, isn't it? Now this becomes sec square A and 1 minus sine square A is cos square A. Now sec and cos are reciprocal to each other, which means sec theta multiplied by cos theta. It will give you 1 only, reciprocal to each other, isn't it? Over here, which means this will give you 1. Proved. Done. Now let us look at the next sum. Now look at 13 part 1. Prove that tan A plus cot A equals to sec A multiplied by cosec A. Very simple. Look over here. Your left hand side. Tan A plus cot A. Now tan we can write sine A by cos A. Similarly, cot A can we write cos A by sine A. Done. Now when we take LCM, this is cos A sine A. Sine A multiplied by sine A gives you sine square A, and cos A multiplied by cos A gives you cos square A. So this becomes what? Sine square A plus cos square A, that's 1 by cos A and sine A. Now 1 by cos A is nothing but sec A because cos and sec are reciprocal. So sec A multiplied by, and 1 by sine is nothing but cosec. Done. And that is equal to RHS. Proved or verified. Done. Now let us look at 13 part 2. Prove that 1 minus cos A, 1 plus sec A equals to tan A sine A. Very simple. Look over here. I'll take left hand side. 1 minus cos A, 1 plus sec A. Now look carefully. This I can write 1 minus cos A. And this can I write 1 plus sec A, can I write 1 by cos A? Definitely. Now this is 1 minus cos A. This if I take LCM, cos A, So 1 into cos A is cos A plus 1. Now this can I write like 1 minus cos A, 1 plus cos A by cos A. Now look carefully. A minus B, A plus B. That's A square minus B square by cos A, isn't it? Now 1 minus cos square A, we know that's sine square A. So that's sine square A by cos A. Now again, sine square A, can I write sine A multiplied by sine A by cos A? Now sine by cos is nothing but tan A multiplied by sine A is left, isn't it? Equals to RHS. Proved. Done. Now let us look at the next sum. Now look at sum number 14, part 1. Prove that 1 by 1 plus cos A plus 1 by 1 minus cos A equals to 2 cosec square A. Very easy. Look over here. The left hand side is what? 1 by 1 plus cos A plus 1 by 1 minus cos A. We'll take LCM. So it's 1 plus cos A multiplied by 1 minus cos A. This goes over here. So 1 multiplied by this remains the same thing. Similarly, 1 plus cos A multiplied by 1 gives you the same thing, 1 plus cos A. Now, cos A cancels out and this becomes 2. And in the denominator, see, A plus B, A minus B, that's A square minus B square, isn't it? Now 2. Now 1 minus cos square A is nothing but sine square A. Now 1 by sine A is cosec A. So 1 by sine square A will be cosec square A, isn't it? And that is equal to RHS. Proved. Done. Now let us look at 14 part 2. Prove that 1 by sec A plus tan A plus 1 by sec A minus tan A equals to 2 sec A. Very simple. Take the LHS. This is 1 by sec A plus tan A plus 1 by sec A minus tan A. Now just look carefully. If I take LCM, this is sec A plus tan A multiplied by sec A minus tan A, and sec A minus tan A multiplied by 1 gives you sec A minus tan A, and sec A plus tan A multiplied by 1 gives you sec A plus tan A. Now look carefully. Tan A cancels out. Sec A plus sec A is 2 sec A, and the denominator, see, sec A plus tan A, sec A minus tan A, which is A plus B, A minus B, which is A square minus B square. So this is 2 sec A, and sec square theta minus tan square theta is 1 identity. So this is 1. So this is RHS. Proved. Isn't it? Very simple. Now let us look at the next sum. Now look at 15 part 1. Very interesting. Prove that sine A by 1 plus cos A is equal to 1 minus cos A by sine A. Now look carefully. In the left hand side, when I'm talking about, we have sine A by 1 plus cos A. And the RHS, in the numerator you have 1 minus cos A. So if we rationalize the denominator in this case, see, if you rationalize this, you have to multiply the numerator and the denominator with 1 minus cos A. So somewhere we'll reach here. Look, rationalize the denominator, which means sine A 1 minus cos A. I am multiplying the numerator and the denominator with 1 minus cos A. Now look, in the numerator you have still this. In the denominator, look over here. A plus B, A minus B, that's A square minus B square, isn't it? So that's sine A 1 minus cos A by sine square A. Now, sine A by sine square A, which means it will be 1 minus cos A, and sine A will be left in the denominator. This is equal to RHS. Proved. Done. Now look at this, 15 part 2, very easy. Prove that 1 minus tan square A by cot square A minus 1 is equal to tan square A. Very simple. Just look over here, left hand side. 1 minus tan square A by cot square A minus 1. Now 1 minus tan square A. If you look carefully, can we write this as 1 minus tan square A? Can I write sine square A by cos square A? Because tan is nothing but sine by cos. Similarly, cot square A, can I write cos square A by sine square A minus 1? We can do like this. Now take LCM, so this is cos square A, isn't it? And this will be cos square A minus sine square A. And in the denominator, if you take sine square A, this will be cos square A minus sine square A, isn't it? Which, when you simplify, becomes something like sine square A by, see, this and this cancels out. So this becomes sine square A by cos square A. Because 1 by cos square A divided by 1 by sine square A. See, it is 1 by cos square A divided by 1 by sine square A. So this will be ultimately sine square A by cos square A, isn't it? Now sine by cos is tan. So this becomes tan square A, which is equal to RHS. Proved. Done. Now let us look at the next sum. Now look at 15 part 3. Prove that sine A by 1 plus cos A is equal to cosec A minus cot A. Just look over here. Left hand side is what? Sine A by 1 plus cos A. Over here also, I'll rationalize the denominator. Whenever there is 1 plus cos A or 1 minus cos A or 1 plus sine A, 1 minus sine A, in the denominator, most of the time we rationalize the denominator. See? Rationalize the denominator, which means we need to multiply the numerator as well as the denominator with 1 minus cos A. How does it help us? See, this is sine A, 1 minus cos A, and in the denominator, this is A plus B, A minus B, that's A square minus B square, isn't it? Now this is what? Sine A, 1 minus cos A by sine square A, because 1 minus cos square A is sine square A. Now sine A by sine square A, which means sine A will be left in the denominator, isn't it? Now look, can I split this as 1 by sine A minus cos A by sine A, which, if you look carefully, 1 by sine is cosec A and cos by sine is nothing but cot A, and that is equal to RHS. Proved. Done. Now let us see 16 part 1. Prove that sec A minus 1 and sec A plus 1 equals to 1 minus cos A by 1 plus cos A. Very simple. Sec and cos are reciprocal to each other. So can I write, just look over here in the left hand side, sec A minus 1 by sec A plus 1. Can I write this as 1 by cos A minus 1, 1 by cos A plus 1, isn't it? Now if I take LCM, this is cos A, 1 minus cos A. In the denominator also, if I take cos A, this is 1 plus cos A. This and this cancels out. So what remains? 1 minus cos A by 1 plus cos A remains. And this is your RHS. Proved. Done. Now let us look at the next sum. Now look at this. 16 part 2. Very easy. Prove that tan square theta by sec theta minus 1 whole square is equal to 1 plus cos theta by 1 minus cos theta. Very easy. Your left hand side is tan square theta by sec theta minus 1 whole square. Now tan square theta, can I write sec square theta minus 1, isn't it? Now look carefully. Sec square theta minus 1, can I write a square minus b square, which is a minus b multiplied by a plus b, by sec theta minus 1 whole square, which means this and 1 square cancels out. So what remains? Sec theta plus 1 by sec theta minus 1. We just did a sum like this. Sec theta, can I write 1 by cos theta plus 1 by 1 by cos theta minus 1. So this is cos theta taken LCM. So 1 plus cos theta. In the denominator also cos theta. 1 minus cos theta. So what remains? 1 plus cos theta by 1 minus cos theta, and this is equal to RHS. Done. Simple, isn't it? Now 16 part 3. Prove that 1 plus tan A whole square plus 1 minus tan A whole square equals to 2 sec square A. Very simple. Just expand left hand side. See, left hand side. 1 plus tan A whole square will be 1 square A square plus B square plus twice AB. Similarly, 1 minus tan A whole square will be A square plus B square minus twice AB. Isn't it? 2 tan A cancels out. So what remains? 2 plus 2 tan square A remains, which is nothing but 2 taking common, 1 plus tan square A, and 1 plus tan square A is nothing but sec square A. So that's 2 sec square A. That is equal to my RHS. Proved. Done. Now let us look at sum number 16 part 4. Very easy. Look over here. What they've done. Prove that sec square A plus cosec square A is equal to sec square A multiplied by cosec square A. Very simple. See, your left hand side, part 4, 16 part 4 is sec square A plus cosec square A. Now sec A, can I write 1 by cos A? So this we can write 1 by cos square A plus 1 by, and cosec A, can I write 1 by sine square A? Reciprocal to each other. Sine A is 1 by cosec A. Now if you take LCM, this is cos square A sine square A, and this will be sine square A plus cos square A. So sine square A plus cos square A is 1. So that's 1 by cos square A sine square A. Now look carefully. 1 by cos is nothing but sec. So 1 by cos square A will be sec square A. And 1 by sine is nothing but cosec. So 1 by sine square A is cosec square A, which is equal to RHS. Proved. Done. Now let us look at the next sum. Now look at sum number 17 part 1. Prove that 1 plus sine A by cos A plus cos A by 1 plus sine A equals to 2 sec A. Very easy. Just look at left hand side. 1 plus sine A by cos A plus cos A by 1 plus sine. Take the LCM. So that's cos A 1 plus sine A, and this multiplies with this gives you 1 plus sine A whole square. This multiplies by this gives you cos square A, isn't it? Now just open this. A plus B whole square, which is A square plus B square plus twice AB plus cos square A by cos A 1 plus sine A. Done. Now look carefully. Sine square A plus cos square A is 1. So 1 plus 1 will be 2 plus 2 sine A by cos A 1 plus sine A, isn't it? Which means if we take 2 common, that becomes 1 plus sine A by cos A 1 plus sine A. So this cancels out. So 2 by cos A. Now 1 by cos A is what? Sec A. So this is 2 sec A equals to RHS. Proved. Done. Now look at this. 17 part 2. Prove that tan A by sec A minus 1 plus tan A by sec A plus 1 equals to 2 cosec A. Very easy. Look at the left hand side. This is tan A by sec A minus 1 plus tan A by sec A plus 1. What I'll do? I'll take tan A common. So what remains? 1 by sec A minus 1 plus 1 by sec A plus 1 remains, isn't it? Now look carefully. Tan A, I'll take LCM. So this will be sec A minus 1 and sec A plus 1, isn't it? This 1 multiplied by sec A plus 1 will be sec A plus 1 plus 1 multiplied by sec A minus 1 will be sec A minus 1. Isn't it? This and this cancels out. So this becomes, just look over here, tan A into sec A by This is a plus b, a minus b, that's sec square a minus 1. Okay, now sec square theta minus 1 is tan square theta, so can I write tan a into sec a by tan square a? Now tan a and tan a cancels out, so it becomes sec a by tan a remains. Now look carefully, sec is 1 by cos a multiplied by tan a is what? Sine a by cos a. Now this cancels out. 1 by sine a is nothing but cosec a equals to RHS. Am I clear? Now let us look at the next sum. Now look at 18 part 1. They've given prove that cosec a by cosec a minus 1 plus cosec a by cosec a plus 1 is equal to 2 sec square a. Very easy. First step, see what I'll do. I'll take cosec a common. So what is left? 1 by cosec a minus 1 plus 1 by cosec a plus 1, isn't it? Now what we'll do? This is cosec a. I'll take LCM. So this is cosec a minus 1 cosec a plus 1, isn't it? This multiplies by this gives you cosec a plus 1 plus this multiplies by this gives you cosec a minus 1. Now look carefully, this and this goes away. So this is cosec a and this is twice cosec a by, now cosec a minus 1 cosec a plus 1, a minus b, a plus b is a square minus b square, isn't it? Now this becomes 2 cosec square a by cosec square a minus 1 is nothing but cot square a. So I can write cot square a. Now look carefully, 2 cosec square a will be 1 by sine square a multiplied by, and cot square a will be cos square a by sine square a, isn't it? This cancels out, so 2 by cos square a. Now cos, 1 by cos is sec, so this becomes 2 sec square a. Done. Now look at 18 part 2. Just look over here. Very easy. Prove that cot a minus tan a equals to 2 cos square a minus 1 by sine a cos a. Take left hand side. See, this is cot a minus tan a. Now cot a is nothing but cos a by sine a, and tan a is nothing but sine a by cos a. Take LCM, so this becomes sine a cos a. Cos into cos is cos square a minus sine a into sine a is sine square a. Now look, this is cos square a minus sine square a. I can write 1 minus cos square a, isn't it? And this is sine a cos a. Now just open the bracket, so this becomes cos square a minus 1 minus plus cos square a by sine a cos a, isn't it? So this becomes 2 cos square a minus 1 by sine a cos a. Done. This is your RHS. Clear? Now let us look at the next sum. Now look at 18 part 3. Very interesting. Prove that cot a minus 1 by 2 minus sec square a equals to cot a by 1 plus tan a. Just look over here. Your left hand side is cot a minus 1 by 2 minus sec square a. Now cot a I can write 1 by tan a minus 1. In the denominator 2 minus sec square a. Now just look, sec square theta is 1 plus tan square theta. So I can write 1 plus tan square a, isn't it? This, if I take tan a LCM, in the numerator I'll get 1 minus tan a. In the denominator you have, open the bracket, so this is 2 minus 1 minus tan square a, which becomes 1 minus tan a by tan a, and this becomes 1 minus tan square a. Just look carefully. So this becomes 1 minus tan a by tan a, and a square minus b square, this is a minus b and a plus b, isn't it? This and this cancels out. Now 1 by tan is cot. So cot A by 1 plus tan A. And this is your RHS if you look carefully. Done. Okay. Now let us look at 19 part 1. Prove that tan square A minus sine square A equals to tan square A multiplied by sine square A. Very easy. Just look over here. Your left hand side is tan square A minus sine square A. Now tan I can write sine square A by cos square A minus 1 minus sine square A. Isn't it? Take LCM. So this is cos square A. So this is sine square A minus, this goes over there, cos square A sine square A. Take sine square A common. So this is 1 minus cos square A will be left by cos square A. Now sine by cos is tan. So tan square A, and 1 minus cos square A is sine square A. This is equal to RHS. Proved. Very easy. Done. Now let us look at the next sum. Now look at 20 part 1. Prove that cosec to the power 4 theta minus cosec square theta equals to cot to the power 4 theta plus cot square theta. Very easy. Just look over here. Your left hand side is cosec to the power 4 theta minus cosec square theta. What I'll do, I'll take cosec square theta common. So what is left? Cosec square theta minus 1. Isn't it? Now look carefully. Cosec square theta minus 1 is nothing but cot square theta. So I can put cot square theta, isn't it? Now again, just look over here. Cosec square theta. Cosec square theta I can write as 1 plus cot square theta. So 1 plus cot square theta multiplied by cot square theta. Just open the bracket. So 1 into this will be cot square theta. Cot square theta multiplied by cot square theta is cot to the power 4 theta. This is your RHS. Proved. Clear? Now look at this. Very interesting. Prove that 2 sec square theta minus sec to the power 4 theta minus 2 cosec square theta plus cosec to the power 4 theta is equal to cot to the power 4 theta minus tan to the power 4 theta. Now what I'll do, 2 sec square theta is nothing but 1 plus tan square theta. Similarly, sec to the power 4 theta I can write sec square theta whole square minus 2 cosec square theta I can write 1 plus cot square theta plus cosec to the power 4 theta I can write cosec square theta whole square. This is my LHS. Now just look carefully. This is 2 1 plus tan square theta minus this is 1 plus tan square theta whole square minus 2 1 plus cot square theta plus this is 1 plus cot square theta whole square, isn't it? I'll just open the bracket. See, 2 plus 2 tan square theta minus this is a plus b whole square. So that will be a square plus b square plus twice ab, isn't it? When you open the bracket. Now this when you open a plus b whole square, when you expand it, you get this only. And this when you open the bracket 2 minus 2 cot square theta plus again you expand it, so a plus b whole square will be a square plus b square plus twice ab. Am I clear? Now just look carefully. Yeah, done. Now just see 2 this is cancelling. Just open the bracket now. So this is 2 tan square theta minus 1 minus tan to the power 4 theta minus 2 tan square theta minus 2 cot square theta. Achha, minus 2 cot square theta plus 2 cot square theta cancels out. So what remained? Plus 1 plus cot to the power 4 theta. Now this cancels out, this and this cancels out. So what remains is cot to the power 4 theta minus tan to the power 4 theta, and this is your RHS. Done. Nice sum. Now let us look at the next sum. We look at 21 part 1. Very easy. 1 plus cos theta minus sine square theta. My sine theta 1 plus cos theta equals to cot theta. Look, I'll take the left hand side. 1 plus cos theta minus sine square theta by sine theta 1 plus cos theta. Now 1 plus cos theta, and sin square theta, can I write 1 minus cos square theta? Can I write like this? Isn't it? In the denominator sin theta, 1 plus cos theta. Now look carefully. This is 1 plus cos theta, and this a minus b and a plus b. Or just open the bracket. Wait. Minus 1 plus cos square theta by sin theta, 1 plus cos theta. So this and this cancels. Take cos theta common. So 1 plus cos theta is left. In the denominator sin theta, 1 plus cos theta is left. Isn't it? Now this and this cancels out. Cos by sin is cot. This is equal to RHS. Isn't it? Verified. Now look, part 2. Prove that tan cube theta minus 1 by tan theta minus 1 equals to sec square theta plus tan theta. Very easy. Look over here. What I'll do, I'll take the left hand side. That's tan cube theta minus 1 by tan theta minus 1. Now a cube minus b cube will be a minus b, a square plus ab plus b square. Isn't it? A cube minus b cube is a minus b factorized, a square plus ab plus b square. Now this and this cancels out. Now tan square theta plus 1 is sec square theta plus tan theta as it is, and this is equal to RHS. See, in 2 steps the sum is done. Okay, now let us look at the next sum. Now look at 22 part 1. Prove that 1 plus cosec A by cosec A is equal to cos square A by 1 minus sin A. Now look over here. What I'll do, I'll change this to 1 plus 1 by sin A by 1 by sin A. Because cosec A, we know, is 1 by sin A. Now take LCM, so that's sin A 1 plus sin A 1 by sin A. Isn't it? This cancels out, so this becomes 1 plus sin A. Okay, now what we do, we multiply the numerator and the denominator by 1 minus sin A. So what becomes? A plus b, a minus b. That's a square minus b square by 1 minus sin A. Just look over here. Now 1 minus sin square A is nothing but cos square A by 1 minus sin A. And this is our RHS. Done. Proved. Now look at this. Very interesting. Important sum. Prove that root of 1 minus cos A by 1 plus cos A equals to cosec A minus cot A. The root has to be removed. So what I'll do, I'll rationalize the denominator over here. Just look over here. This was 1 minus cos A by 1 plus cos A in the left hand side. What I'll do, rationalize the denominator. So I'll multiply by 1 minus cos A up and down. Isn't it? Now see, in the numerator it is 1 minus cos A whole square. In the denominator, a plus b, a minus b, that's a square minus b square. So that's root of 1 minus cos A whole square, and 1 minus cos square A is sin square A. Now the square and the root goes away, so this becomes 1 minus cos A by sin A. Now we split it, so that's 1 by sin A minus cos A by sin A. 1 by sin A is nothing but cosec A, and cos A by sin A is cot A. And this is our RHS. Done. Now let us look at the next sum. Now look at 23 part 1. Root of 1 plus sin A by 1 minus sin A equals to tan A plus sec A. Very easy. We know what to do. Rationalize the denominator. See, you have 1 plus sin A by 1 minus sin A. What I'll do, rationalize the denominator, which means I'll multiply by 1 plus sin A and 1 plus sin A, the numerator and the denominator, which after rationalizing becomes 1 plus sin A whole square by, see, a plus b, a minus b, that's a square minus b square. So that's root of 1 plus sine a whole square. And this is cos square a. Done. Now, the square and the root cancels out. So what remains? 1 plus sine a by cos a. Now we split it. So 1 by cos a plus sine a by cos a, which is 1 by cos a is sec a plus sine a by cos a is tan a. That is your RHS. Proved. Clear. 23.2 is similar. You just rationalize the denominator and the right hand side will be there. Am I clear? Now let us look at the next sum. Now look at 24 part 1. Root of sec a minus 1 by sec a plus 1 plus root of sec a plus 1 by sec a minus 1 equals to twice of cosec a. Very easy. I'll take the left hand side. See, root of sec a minus 1 by sec a plus 1 plus root of sec a plus 1 by sec a minus 1. So what I'll do, I can take LCM and this will be root of sec a plus 1 multiplied by root of sec a minus 1. The root of sec a minus 1 multiplied by root of sec a minus 1, which becomes sec a minus 1. Isn't it? Similarly, root of sec a plus 1 multiplied by root of sec a plus 1. It becomes sec a plus 1. Isn't it? A minus 1 plus 1 cancels out. So this becomes twice of sec a. And the denominator you see, sec a plus 1, sec a minus 1 under root. So this becomes a plus b, a minus b. That's a square minus b square. So that's twice of sec a root of, and this is sec square a minus 1 is tan square a. So that's twice of sec a by tan a. This becomes twice of sec a, becomes 1 by cos a, and tan a I can write sine a by cos a. So 2 by sine a is nothing but 2 cosec a. Done. Now let us look at sum number 24 part 2. Cos a cot a 1 minus sine a equals to 1 plus cosec a. Very easy. Look over here. Left hand side. We have cos a cot a by 1 minus sine a. Now cos a cot a, can I write cos a by sine a, and 1 minus sine a was already there in the denominator. Cos a is cos square a by sine a, 1 minus sine a. Now cos square a will be 1 minus sine square a, isn't it? We can write it like this. Just look carefully. Now 1 minus sine square a, can I write a square minus b square, which is a minus b multiplied by a plus b. Can I write like this? In the denominator we have sine a, 1 minus sine a. Just look over here. This cancels out. So what remains? 1 plus sine a by sine a. Now we split it. So 1 by sine a plus sine a by sine a. 1 by sine a is cosec a plus sine a by sine a is 1, which is your RHS. Done. Now let us look at the next sum. Now look at this sum. Prove that 1 plus tan a by sine a plus 1 plus cot a by cos a equals to twice of sec a plus cosec a. This is 25 part 1. In this type of sum, in majority of the sum, when tan and cot are there, we'll change tan to sine by cos and proceed. Because these are two function of sine or cos only. Sec is nothing but 1 by cos, okay? So what I'll do, in the left hand side, just look carefully. 1 plus, instead of tan a, can I write sine a by cos a by sine a plus 1 plus cos a by sine a by cos a, isn't it? Which means if I take the LCM cos a, this becomes cos a plus sine a by sine a plus similarly this sine a. So this becomes sine a plus cos a if I take sine a as LCM by cos a, isn't it? So these two are multiplied. We know this. So this becomes cos A plus sin A by sin A cos A plus sin A plus cos A by sin A cos A. Now you take LCM. So sin A cos A is LCM. So this remains as it is, cos A plus sin A plus sin A plus cos A, isn't it? So this becomes twice of cos A plus twice of sin A by sin A cos A. Now split it. So this becomes twice cos A by sin A cos A plus twice sin A by sin A cos A, isn't it? This cancels out. 2 by sin A is nothing but 2 cosec A, and 2 by cos A is nothing but 2 sec A. Take 2 common, so that becomes cosec A plus sec A, which is your RHS. Proved. Now let us look at the next sum. Now look at this sum, 25 part 2. Very easy. Prove that sec to the power 4a minus tan to the power 4a equals to 1 plus 2 tan square. See, our left hand side is sec square a whole square, isn't it? Minus tan square a whole square. This is a square minus b square. That's a minus b. A plus b. Now look carefully. Sec square theta minus tan square theta is 1. Okay. And sec square theta, again I can write 1 plus tan square a plus tan square a, isn't it? So that becomes 1 plus 2 tan square a. Done. And that is your RHS. Very easy. Look over here. 26 part 1. Prove that cos sec to the power 6a minus cot to the power 6a equals to 3 cot square a cosec square a plus 1. Now look carefully. We know a cube minus b cube can be written as a minus b whole cube plus 3ab a minus b. Remember? Now this, your left hand side, can I write cosec square a whole cube minus cot square a whole cube. Now, a cube minus b cube is what? Look over here. A minus b whole cube plus thrice a b a minus b, isn't it? A minus b. Now we know cosec square theta minus cot square theta is 1. So we'll substitute the value 1 plus 3 cosec square a cot square a, and this is also 1. And this is our RHS, 3 cot square a cosec square a. So this is equal to RHS. Proved. Am I clear? 26 part 2 is similar. You know, sec to the power 6a minus tan to the power 6a. Proceed the same manner. Okay, you will get the answer. Now let us look at the next sum. Now look at the next sum. Very interesting. 27 part 1. Prove that cot theta plus cosec theta minus 1 by cot theta minus cosec theta plus 1 equals to 1 plus cos theta by sin theta. Very easy. Look at left hand side. We have cot theta plus cosec theta minus 1 by cot theta minus cosec theta plus 1. Now look carefully. Cosec theta. Now minus 1. Can I write 1 as cosec square theta minus cot square theta? I can write like this, isn't it? In the denominator as it is. Now see, in the numerator, cot theta plus cosec theta minus a square minus b square is a minus b, a plus b, isn't it? By, this is cot theta minus cosec theta plus 1. Now look carefully. This cot theta plus cosec theta is common in these two terms. So I'll take cot theta plus cosec theta common. So what is left? Over here 1 is left. Over here minus cosec theta minus cot theta is left, isn't it? By cot theta minus cosec theta plus 1. Now this, if you look carefully, this is cot theta plus cosec theta. This is 1 minus cosec theta plus cot theta by cot theta minus cosec theta plus 1. These two terms are same. So what remains? Cot theta we can write cos theta by sin theta plus cosec theta we can write 1 by sin theta. Take sin theta LCM, so this becomes cos theta plus 1, and that is your RHS, isn't it? Now let us look at the next sum. Now look at this sum, 27 part 2. Prove that sin theta by cot theta plus cosec theta equals to 2 plus sin theta by cot theta minus cosec theta. What we will do? We'll simplify the left hand side, we'll simplify the right hand side, and see that both have the same value. Look over here. The left hand side, sin theta by cot theta, can I write cos theta by sin theta? Cosec theta, can I write 1 by sin theta? Which means this becomes sin theta by, I'll take sin theta LCM, so this is cos theta plus 1. This goes up, that becomes sin square theta by cos theta plus 1. Now sin square theta I can write 1 minus cos square theta by cos theta plus 1. Now a square minus b square, can I write a minus b, a plus b by cos theta plus 1. So this and this cancels out. What remains? So when you simplified the left hand side, we got 1 minus cos theta. Now we'll simplify this also. Just look over here. 2 plus, this is sin theta. Cot theta is cos theta by sin theta minus 1 by sin theta. This is 2 plus sin theta by sin theta taken LCM. So this is cos theta minus 1, isn't it? Now these two gets multiplied. So it becomes 2 plus sin square theta by cos theta minus 1, isn't it? See, 2 plus sin square theta, I can write 1 minus cos square theta by cos theta minus 1. Now 2 plus, this is 1 minus cos theta, 1 plus cos theta. Now look carefully, in the denominator what I'll take minus 1 common. So this becomes 1 minus cos theta now. Why I did this? Because this and this cancels out. So this becomes 2 plus minus minus 1 plus cos theta. Just open the bracket. So 2 minus 1 minus cos theta. That's 1 minus cos theta. So LHS is equal to RHS. Hence this is equal to this. Proved. Now let us look at the next sum. Now look at 28 part 1. Prove that sin theta plus cos theta multiplied by sec theta plus cosec theta equals to 2 plus sec theta cosec theta. Very easy. We'll take the left hand side. See, can we write this as sin theta plus cos theta? Sec theta, can I write 1 by cos theta plus cosec theta 1 by sin theta? I can write like this. So this is sin theta plus cos theta. If I take LCM, so cos theta sin theta LCM, this is sin theta plus cos theta, isn't it? Now sin theta plus cos theta, sin theta plus cos theta, multiply these two. So you'll get sin square theta plus cos square theta plus twice sin theta cos theta, because that's a plus b is a plus b whole square by cos theta sin theta. Sin square theta plus cos square theta is 1. So that becomes 1 plus 2 sin theta cos theta by cos theta sin theta. Split it. So that becomes 1 by cos theta sin theta plus 2 sin theta cos theta by sin theta cos theta, isn't it? This and this cancels out. Now 1 by cos is sec theta, 1 by sin is cosec theta, plus 2 is left over here, and this is our RHS. Done. Now let us look at the next sum. Now look at this sum, 28 part 2. Prove that cosec A minus sine A, sec A minus cos A multiplied by sec square A equals to tan. Very easy. Look over here. Left hand side. Cosec A, can I write 1 by sine A minus sine A? Sec A, can I write 1 by cos A minus cos A? And sec square A as it is. Now look carefully. If I take LCM, this is sine A. This becomes 1 minus sine square A. If I take LCM cos A, this becomes 1 minus cos square A. This is sec square A as it is. 1 minus sine square A is cos square A by sine A, multiplied by 1 minus cos square A will be sine square A by cos A, multiplied by sec square A. Now sec and cos are reciprocal to each other, which means cos square A multiplied by sec square A will give you 1. So and sine square A, sine A. So square cancels out. So what remains? Sine A by cos A remains, and that is nothing but tan A. And this is our RHS, isn't it? Now let's look at the next sum. Now look at this sum, 29 part 1. Prove that sine cube A plus cos cube A by sine A plus cos A plus sine cube A minus cos cube A by sine A minus cos A equals to. Very easy. A cube plus B cube. What is the formula? I'll take LHS, okay? A cube plus B cube is A plus B A square minus AB plus B square, isn't it? By sine A plus cos A, isn't it? Plus, same over here. A cube minus B cube is what? A minus B A square plus AB plus B square by, and this is sine A minus cos A, isn't it? Now look at it. This cancels out. So what remains? If you look carefully, sine square theta plus cos square theta is 1. So 1 minus sine A cos A over here. Over here also sine square A plus cos square A is 1. 1 plus sine A cos A remains. This and this cancels out. This becomes 2. Done. Very easy. Look at 29 part 2. Very easy. Tan square A by 1 plus tan square A plus cot square A by 1 plus cot square A equals to 1. You have to prove. Look, left hand side. Tan square A. Now, 1 plus tan square A is sec square A. We know. This is cot square A. 1 plus cot square A is nothing but cosec square A. We know this. Now, tan is what? Sine square A by cos square A multiplied by sec square A. Similarly, cot is what? Cos square A by sine square A multiplied by cosec square A. Now, cos and sec are reciprocal, which means cos square A multiplied by sec square A is 1. So, sine square A plus cos square A will be left. Similarly, over here, sine square A into cos square A, cosec square A is 1. Now, sine square A plus cos square A is 1. That's your answer, okay? That's RHS. Done. Now let us look at the next sum. Now look at this sum. Very interesting and very important. 30 part 1. Prove that 1 by sec A plus tan A minus 1 by cos A equals to 1 by cos A minus 1 by sec A minus tan A. Very simple. Look over here. Okay. Your LHS. I solve LHS and RHS, simplify it and get the same value. See? 1 by sec A plus tan A minus 1 by cos A. Now 1. Can I write 1 as sec square A minus tan square A? Sec square A minus tan square A. Denominator as it is. Just look carefully. And 1 by cos A is nothing but sec A. Now sec square A minus tan square A, can I write sec A plus tan A plus B multiplied by A minus B, isn't it? By sec A plus tan A as it is, minus sec A. Done. Now look, this and this cancels out. So what remains? Sec A minus tan A minus sec A, which means minus tan A remains. Now if we can prove that RHS when simplified gives us this value, our work is done. Look carefully, your RHS. Same manner I'll do. Look carefully. What I'll do, 1 by cos A is sec A minus 1. I can write sec square A minus tan square A by sec A minus tan A. Isn't it? So this is sec A minus A square minus B square is A minus B A plus B. Isn't it? And this is sec A minus tan A as it is. This and this cancels out. When you open the bracket, sec A minus tan A, isn't it? This and this cancels out. What remains is minus tan A. So LHS is equal to RHS. Proved. Done. Now let us look at the next sum. Now look at this 30 part 2. Prove that sin A plus sec A whole square plus cos A plus cosec A whole square equals to 1 plus sec A cosec A whole square. Not to worry. We'll just solve our LHS. Look over here. I'll just open the bracket. Sin A plus sec A whole square will be sin square A plus sec square A plus 2 sin A sec A. Isn't it? Similarly, I'll open this bracket. Cos square A plus cosec square A plus 2 cos A cosec A. Can I write like this? Now look. Sin square A plus cos square A is 1. So 1 plus sec square A plus cosec square A plus this is what? 2 sin A sec A plus 2 cos A cosec A. Isn't it? Just look carefully. So this becomes 1 plus sec square A plus cosec square A. 2 taken common. Now this can I write? This one sin A. Sec A is 1 by cos A plus cos A. Cosec A is 1 by sin A. I can write like this. Isn't it? So this is 1 plus sec square A plus cosec square A plus twice. I'll take LCM. So cos A sin A is LCM. So this becomes sin square A plus cos square A. Isn't it? This goes over there, this goes over there. So this becomes, now this becomes, if you look carefully, just look over here. This becomes 1. So this is 2 by cos A sin A. Done. Now look carefully. I can write this as 1 plus sec square A. This, wait. I can write 1 by cos square A plus 1 by sin square A plus 2 sec A cosec A. Isn't it? Now these two again, if I'll take LCM, look over here. This is cos square A plus A multiplied by sin square A. This becomes over here. So this becomes sin square A plus cos square A. Isn't it? Plus 2 sec A cosec A. Now this is 1. Okay. So what remains? 1 plus 1 by cos square A sin square A plus 2 sec A cosec A remains. Now 1 by cos becomes sec. So that becomes 1 plus sec square A cosec square A plus twice sec A cosec A. Am I clear or not? Now look carefully. A square plus B square plus twice AB, which means 1 plus sec A cosec A whole square. Isn't it? Formation of perfect square. This is your RHS. Done. Now let us look at the next sum. Now look at sum number 31. If sin theta plus cos theta is root 2 sin 90 minus theta, Show that cot theta equals to root 2 plus 1. Very easy. See what is given. Always we'll start what is given to us. From there we'll start. This is given to us. Now we know complementary angle. Sin 90 minus theta is cos theta. So sin theta plus cos theta equals to root 2 cos theta. Now what I'll do, I'll divide the entire thing by cos theta. So sin theta by cos theta plus cos theta by cos theta is 1 equals to root 2, because cos theta by cos theta is 1. Sin theta by cos theta is tan theta. So tan theta equals to root 2 minus 1. We got tan theta. So what is cot theta? Reciprocal of this? Done. Now rationalize the denominator, because root should not be there in the denominator. So when you rationalize root 2 plus 1 by root 2 plus 1, rationalize the denominator. So that's root 2 plus 1 in the denominator, root 2 square minus 1 square. That's root 2 plus 1. That's 2 minus 1. That's root 2 plus 1. So cot theta is nothing but root 2 plus 1, isn't it? That is what we were supposed to prove. Done. Now look at 32. If 7 sin square theta plus 3 cos square theta equals to 4 and theta is acute, find theta. Very easy. Look over here. 7 sin square theta plus 3 cos square theta equals to 4. Now can I write 7 sin square theta plus 3 cos square theta 1 minus sin square theta equals to 4? Open the bracket. So 7 sin square theta plus 3 minus 3 sin square theta equals to 4, isn't it? But 7 minus 3 is 4. So 4 sin square theta equals to 4 minus 3 is 1, which means sin square theta is 1 by 4, which means sin theta equals to 1 by 2. Will not take the negative 1 because theta is acute, and for theta acute, sin is always positive. Now when is the value of sin theta half? At sin 30 degree, which implies theta is nothing but 30 degree, and that's your answer. Done. Now let us look at the next sum. Now look at sum number 33. Very easy. If sec theta plus tan theta equals to m, sec theta minus tan theta equals to n, prove that mn equals to 1. These two expressions are there. You just multiply them. Suppose this is equation 1, this is equation 2. Multiply 1 and 2. So what you'll get? Sec theta plus tan theta, sec theta minus tan theta is equal to m into n. But this is a plus b, a minus b is nothing but a square minus b square equals to mn. Now sec square theta minus tan square theta is 1. So 1 equals to mn. Proved. 3 steps. You have to see over here, see. Mn was multiplied. This was m, this was n. So we'll just multiply these two. Done. Now look carefully. 34. If x equals to a sec theta plus b tan theta, y equals to a tan theta plus b sec theta, prove that x square minus y square is equal to a square minus b square. Very easy. See, x square. So squaring both sides of this. Y square. Squaring both sides of this. And then you subtract. Look carefully. Squaring both sides. What do you get? X square equals to a sec theta plus b tan theta whole square, which means x square equals to, I'll open the bracket, a square plus b square plus twice a b. Isn't it? That's the formula. Which means your x square will be, keep it like this. Now I'll find y square. Look over here. Squaring both sides, I'll get y square equals to a tan theta plus b sec theta whole square. So y square equals to, I'll just open the bracket, a square plus b square plus twice a b. Isn't it? Now this is your expression 1, this is your expression 2. 1 minus 2. X square minus y square equals to, x square is what? A square sec square theta plus b square tan square theta plus twice ab sec theta tan theta minus this entire thing. A square tan square theta minus b square sec square theta minus twice AB tan theta sec theta. And if you look carefully, twice AB sec theta tan theta cancels out. So what remains? X square minus y square is a square sec square theta minus tan square theta. If from this and this I take a square common, similarly I'll take b square common, so b square, so tan square theta minus sec square theta, isn't it? Now just look over here. Sec square theta minus tan square theta is 1 plus b square. Tan square theta minus sec square theta will be minus 1 because sec square theta minus tan square theta is 1. If suppose a minus b is 1, then we can say b minus a is minus 1. So I'll put minus 1, which means a square minus b square. Done. Now let us look at the next sum. Now look at the last sum for this exercise. If x equals to h plus a cos theta and y equals to k plus a sin theta, prove that x minus h whole square plus y minus k whole square equals to a square. Now, x minus h whole square. So what I'll do, I'll bring h on this side and then squaring both sides. So it will be x minus h whole square equals to a square cos square theta. Similarly, I'll bring k on this side and then squaring both sides. So y minus k whole square equals to a square sin square theta. I'll add these two expressions. Just add them. What you'll get? X minus h whole square plus y minus k whole square equals to a square cos square theta plus a square sin square theta. Isn't it? Take a square common, so that becomes cos square theta plus sin square theta. And cos square theta plus sin square theta is a square, which means x minus h whole square plus y minus k whole square equals to a square. And this was the last sum for this exercise. Keep it till here for the day. In the next video, we'll look at a new chapter. Till then, take care.